Right. Greetings, ladies and gentlemen. Welcome to Exploring Industrial Engineering. It's a Wednesday. We are on Learning Unit 3. Thank you so much for being part of this session. I hope you're going to enjoy today's session. Please don't hesitate to email us concerning any general queries related to today's session. Make sure that you also keep your eye on the chat box where I'll be sending information regarding today's session. Without wasting time, I'll hand over to Mr. Johannes for the house rules. Over to you, Mr. Johannes.
Thank you so much, Tamila. Welcome everybody to today's session. We only have a few small house rules for today. We'd like to ask everybody to please mute your cameras to save data and bandwidth. Also to mute your microphones to keep all the background noise to a minimum. If anybody has a question at any point in time, please feel free to raise your hand. Or if you have some mic problems, please put it into the chat area. And then I'll hand over to our presenters for today. Thank you very much.
Thank you, colleagues. So we are going to do Learning Unit 3 today, which is Applications of Industrial and Systems Engineering to Solve Real-Life Problems, which is Learning Unit number 3. So, but before we do that, we want to play a video. I hope we won't have glitches like yesterday, where I accidentally opened 2 links and the video was somehow scrambled when the guys were talking. So I will share my screen now, then we will look at the video, then we will then go straight to the presentation.
Okay, I can see a screen.
Okay, let me close my stuff here first.
The amount of supplies on the shelves.
Is it audible?
It's
Yes,
go.
Proactively, we look ahead.
The different pieces of a system are so interconnected.
Is the video audible to everyone?
Yes.
Oh, okay, super. So let me start it again.
The amount of supplies on the shelves.
There's so much happening here. It's go.
Proactively, we look ahead.
The different pieces of a system are so interconnected.
Tom Rust is a systems engineer. Ashley Benedict is an industrial engineer. Together, they're working to improve the nation's health.
I work for the New England VERC.
The VERC, the Veterans Engineering Resource Center, is a group of systems engineers and industrial engineers who all work to bring systems engineering methods into hospitals.
Whether it's healthcare, fabric care, making cars, or even building the International Space Station, systems and industrial engineers create and improve workflow.
Systems and industrial engineering is the study of how all the different components of a system, and that could be machines, it could be people, it could be resources, how those different pieces all fit together to produce the result that you're seeing.
I can create a system that skims off some time where a physician could spend more time with a patient, then I'm making a difference.
I've only been working in hospitals for about 2 years now, and it's amazing.
From the supply room to the operating room, Tom and Ashley analyze how different aspects of the hospital function. They create strategies for improvement, which lower costs and result in better medical care for the patients they serve. In some cases, their work helps save lives.
You have to go to the place where the work is being done. You have to really observe by yourself.
VERC is designing a training program, a simulation where doctors can practice central line insertion. It's a procedure that enables a doctor or nurse to administer medicine and obtain diagnostic information.
If you ask a resident, have you put in a central line? Most likely they're going to say yes. They've done it at some point. The problem is that every hospital does it differently. So one of the things we're trying to do is minimize that variability. And we've created a process where the resident can use a human simulator and can get comfortable with the supplies they have available, the equipment that's available.
Reducing the variability of the central line procedure saves valuable time for the medical team and decreases the risk of infection to the patient.
Here's the course manual that we like to go over and get your opinion.
I spent some time back here at my desk building computer simulation models and talking to my coworkers about how the modeling is going to go, what are the important parameters that we need to consider, what are the model boundaries going to be. We often go on inpatient rounds with the attending doctors and their residents just to get a sense of how that works.
We contracted IR for skin tissue sampling today, and also we had an order placed for a TPE.
We've worked with the systems engineers to actually improve care. For example, our daily routine morning labs, blood work, only came back late in the afternoon. And this would delay all kinds of clinical care and systems issues like late discharges and so on.
After we built our model and came up with our optimal policy, we found we needed fewer people drawing blood. They could, with this optimal route, start later, spend less time doing the work, let patients sleep longer, and we had a higher reliability of getting all the data that docs need when they needed it.
From today, 78% neutrophils.
Got the fever, but his white count overall
Coming
is
down. Yes.
now almost 90+% of the labs come back by 9 a.m. And that's made an actual difference in the clinical care we provide our patients. We make quicker decisions, we make the right decisions.
Systems engineers find ways to make every component of a complex system work together better. They manage large projects and help organizations figure out where there's room for improvement. Industrial engineers develop strategies to make things happen better and more efficiently. From hospitals to transportation systems to communications, an industrial engineer can improve the way we do just about anything.
My background is more human factors, so looking at how humans interact with technologies,
please open door for tug.
Other people, the environment, their simulations, operations, facility layout, supply chain management, operations research.
You'll find industrial and system engineers in both the private and public sector.
Because the world is so complicated, everything really is part of a system. So you could work in a hospital, you could work in a manufacturing site, you could work for the government, you could work basically anywhere where groups of people get together to try and produce something.
That's what's so great about industrial and systems engineering, is that you're not pigeonholed into one specific thing.
Tom has been working with the VA's Compensation and Pension Service, or C&P.
The turnaround time on the exams has got to have decreased over there because
they expedite medical coverage benefits for disabled veterans recently discharged by the military. VA hospitals provide about 800,000 C&P disability exams each year. In spite of increased demand, systems engineering methods are helping reduce exam wait time.
When I started here, the wait time for an appointment was over 50 days. Now in the VA, after we've done the research and had some of our policy recommendations implemented, it's now less than 7 days.
Yeah, I mean, it's a fabulous system. I mean, I've been espousing it to other C&P directors.
Oh, okay.
Connecticut's very interested in it. It just cuts down the traffic so much from regional office to here.
It's pretty amazing to think that there are probably tens of thousands of people now that don't have to wait for their care because of something that I've done, because of something that we here as systems engineers have done.
Supplies and equipment inventories are an essential part of any healthcare provider system. Hospital managers need to know how much to order, when to order, and what to order.
So one of the inventory projects we're working on is with the operating room, and they have supplies within the operating room. They also have supplies in a room outside of the operating room in a location with an array of supplies, and it's far away from the operating rooms.
if Jen's not here and I have someone who's not familiar with the words we're using, with the terminology, and I tell them to get, you know, a Comfy catheter that looks like 12 or 13 other catheters hanging right next to each other, and the right one doesn't come back. That's where engineering really can help us.
Systems and industrial engineers often have a Bachelor of Science degree in industrial, mechanical, or electrical engineering.
What I like most about industrial and systems engineering is the people aspect.
Boston is such a big, small town. I love how many things there are to do here, how many sites there are to see. You can bike across town in an hour. We know how to do all this exciting new stuff. But how do all these new things fit together?
We've always recognized that there were systems problems, but these guys came in and there's a fresh perspective and they say, oh, you know, this is broken and you could fix it doing this. And we're like, oh, there's a solution to it.
You get to see those aha moments.
I could optimize that and show somebody in numbers and they go, oh, big deal, you're showing me a bunch of numbers, who cares? But if you show them a simulation of it, then it clicks and they get it and they can say, wow, okay, I see why we need to fix this area. You know, you adjust.
It is so great to be able to see the impact of your work, to be able to physically go down and talk to a veteran, to talk to a patient, and to see how their lives have been changed by the fact that the system that they're in now works for them.
Afternoon again. Thank you for listening through the presentation there. And I'm sure you saw the application of industrial and systems engineering in a hospital environment. I'm going to go to the presentation now, then we will quickly go through everything again. Is the presentation visible to everyone?
Sorry, Cabo.
Yes.
If I can come in.
Yeah, go ahead.
I think we need to do a little bit of reflection on what we've just saw. So if you give me an opportunity, I can, you know, pick up a little bit in terms of what has just been shown.
Yes,
So
yes, go ahead.
some of the aspects that were there was, you know, inventory. You know, what is inventory? Inventory is money lying around. And how do we use that money lying around to the best for our patients in terms of optimizing what we need to do? So as they mentioned, so there are various parts coming together to make the organization work as effectively as possible. And they also mentioned operations research. So if we had to look at what operations research is, it is basically an analytical method of problem solving and decision making that is useful in the management of organizations. So in operations research, problems are broken down into basic components and then solved in defined steps by mathematical analysis. Another very important aspect that was mentioned there was simulation. Simulation is basically replicating the original. So replicating meaning I'm not in a hospital, you will not use a human being for an experiment, but you will use a simulated, basically a torso, you know, a plastic rubber made component that you will use to do your experiments on. And also in inventory, you will think about, you know, a very, very simple inventory is in your home. You buy goods, yeah, you buy your groceries and so forth. You want to use it last in? No, you don't want to use the LIFO method. You want to use neither do you want to use the first in, first out. because your first in, first out will basically store your goods that you have bought already before you use it. So it will basically use the LIFO method, last in, first out. So whatever you bought last, although I bought groceries today, whatever I bought last will be used first before I use the one that I have now, in simple terms. So these are some very, very important concepts that were basically portrayed. And another thing that we look at in problem solving, as we mentioned previously, there is a selection of the problem. Which problem gives you the greatest impact? I mean, you have millions of problems every day, but you're not going to look at the problem that does not create an impact. You're going to select that problem that will ensure that you have the greatest impact. So also in reflecting on the other day, some of the terminology in work study, we have select, record, examine, develop, define, install, maintain. So these are some of the issues that we basically practice in industrial engineering, where we can create the greatest impact that will make the most impact to the organization, and that's the way we basically go about selecting the problems that we need to resolve. Thank you so much, Kabo. I'm going to stop there.
Thank you, Prof, for that. And yeah, so I think the most important things you have picked up there, and what I found also interesting is the application of Six Sigma. They did not talk about Six Sigma there, but if you want to reduce variations, variation is enemy to your process because you cannot plan accordingly. So you can use Six Sigma as a tool, and I think we spoke about the tools yesterday, as a tool to reduce variation in processes so that you can better predict what is going to happen today, tomorrow, and in the future. But at the same time, they want to reduce patient waiting times, because waiting is waste. So you want to ensure that patients, when they come to the hospital, are able to come in, go through the process, see the doctor, and go home, and not spend hours in, hours out in a queue waiting to see a doctor. That is waste. I mean, spending the whole day at hospital and only be seen at 2, or worse. Sometimes we know in our country where people, you are cut off the line maybe at 3. You've been there since 7, and at 3 they said no, come back tomorrow. It's just not acceptable. It's not acceptable. And industrial and systems engineers are there to ensure that these things are done. So if government, if government can see the value of industrial and systems engineers and be able to employ those people, things will work best. So I'm going to share my screen here. I actually wanted to, I've closed it. I wanted to pose a question to everyone here. Can you allow me to do that? Just give me a second. I want to just take out this and share it so that you can tell me what you see here.
We are not seeing anything for now, Mr. Kabo.
Okay, no, I will show it again now.
Right.
Okay, so let's share again. Can you see?
Yes.
What do we see here? You can tell me what they see.
I'll engage with you, Mr. Khabo.
Yes, go ahead.
I'm seeing a gentleman and a lady in a nice scenery.
Yes, okay. Any other person who can, because you can see a couple here, and there's a nice scenery here. I think it's a lake or something.
I just see the other dimension, Khabo.
Yes. Which one do you see?
I see the baby.
You see a baby.
I see the baby.
Yes. Can we all see the baby?
Yes,
can we all see the baby?
I see the baby, yeah.
Okay, now I'm seeing a baby.
Can you see the baby, Tumel?
Now I'm seeing the baby.
Okay, so let me show you. So just follow my cursor. Here is the head, is the nose, is the mouth, the eye, and the arms. And here's the belly. Here's the legs. Can you see it now?
Yes. Yeah, you have to train your eye though, hey, Khabo.
So you can see it now, eh?
Yeah.
Yeah. So you know, industrial and systems engineering are, you know, about, you know, seeing you when an organization has to rearrange its mental furniture, be able to see things that might not be obvious to the eye, but they are obvious. For instance, in a hospital administrator might not see inventory, as Prof was saying, as waste. And in fact, you need to have the correct amount of inventory, because inventory is money. So is money lying around there and not being used at the right time, right place, by the right people. So industrial and systems engineering is about integrating all these systems, be it human resources, be it machinery, be it information, be it energy, so that you can develop integrated systems that are able to operate efficiently and effectively. So let's go to the presentation. Slideshow from the beginning. Okay, so we can see the presentation.
Yes.
Okay, thank you.
Yes, from my side.
All right. So we're talking about applications of industrial and systems engineering to solve real life problems. And as you saw in the video, where industrial and systems engineering are used to solve real life problems in hospitals, for instance. And I said that industrial and systems engineers apply analytics and critical decision-making skills to optimize complex processes, because health systems can be very complex and you've got lives at stake. So you need to be very thorough and meticulous in doing what you do. So optimizing all these complex processes and systems and networks, investments, organizations in nearly all sectors of activity, including energy, finance, healthcare, logistics, manufacturing, production, telecoms, and transportation. And you have seen now in the video implementation of the same industrial and systems engineering tools in a hospital. Can even in municipalities, if you know, if governments across the world can really understand the importance that industrial and systems engineer can play in optimizing their systems and their processes, I'm sure we will not have what we are having now with Eskom, and we will not have what we're having now in municipalities, where you drive and there are tar roads, potholed everywhere. Water is not coming to communities, things like that. It's a lack of foresight sometimes that is causing all this. So we're going to talk about industrial engineering tools. We spoke about most of them yesterday, manufacturing, so you can apply IE, and which is industrial engineering. We always call it IE, and systems engineering in you saw in manufacturing, finance, defense, information technology, healthcare. We just saw an example in education and research, in military, how battles can be fought. Industrial engineers and system engineers can come with processes and systems to optimize the battlefields, but we don't want that. We see what is happening there in Ukraine and Russia. War is not a good thing. Marketing, sales, supply chain, and all those applications. SIE, which is industrial and system engineering, solving real life problems. The first one is industrial and systems engineers are involved in commissioning big budgets. For instance, you want to, before you do anything, you must justify budgets, justify spending, and it is the core of industrial and systems engineering to be able to justify spending and make sure that we optimize cost and there's no waste in whatever system or process or whatever equipment that we're building or installing or improving. Other real-life problems, industrial engineers optimize profit or profit maximization. So in operations research, I think you had the lady there speaking about operations research. In operations research, you either maximize or minimize. So you can either maximize profit and minimize cost, maximize throughput and minimize raw material wastage, for instance, things like that. The second one is actually, I just spoke to it now. This is cutting cost. How do you do cost optimization? Weighting. How do we solve issues of weighting? Industrial and systems engineers in banks, they are responsible for developing queuing theories and queuing lines so that you can have the right capacity to handle the right peak at the right time. Issues of transportation, smart transportation, industrial and systems engineers play quite a lot of role in terms of integrating all of these different systems to make them one complex system that is able to work effectively and efficiently. Lead time, how do you reduce lead times? For instance, if you are to wait, let's say you go for a CT scan in a hospital and you have to wait for, is it days or maybe a month, depending whether it is private or public, waiting for results to come. And we are seeing it now in the DNA database in the South African Police Services, where to do a DNA analysis takes months in and months out and delays justice because victims are unable to get justice as this thing drags forever. So how do we reduce lead times, whether it is in production, whether it is in a hospital? How do we optimize demand and supply so that the two are just perfect? And also issues of raw material and inventory. How do we ensure that you have the right inventory at the right level that is going to be distributed to the right place and will be used at the right time? Here it is industrial and systems engineers do automation of plants. You can see here it is a production line that is optimized and it is smart. You can see the operator here is using his or her laptop or whatever handheld device to control machinery, and there are sensors everywhere. So sensors on the assembly line itself and on the robots, and they're able to take instructions. And this is in the 4IR space where previously you'd have workers here everywhere, but now you have robotic arms that are doing the work. So it means that we need to find ways of, one of the real life problems is that while you automate, unemployment might tend to go up. How do you retrain and reskill the workforce so that they are able to play a role in this new digital era that is upon us? And we cannot run away from it. We have to embrace it. It is here to stay. And if we don't embrace it, we will be swept to the side as a country. This is an example that we just had now in the hospital. How do you solve supply and demand from a patient flow point of view? Because industrial and systems engineers, their role is to ensure that you improve the journey of the patient, because the patient doesn't want to sit in that bench for 4 hours. The patient want to come, sit there a bit, get the admin sorted out, then be able to see the doctor. Either you are going to be, you go to the pharmacy to get your medication, or you are going to be sent to the ward. Maybe there's something that they need to do further investigation on, and you have to be admitted to hospital and things like that. So how do you improve this whole system and make sure that it is optimal? It is the realm of the industrial and systems engineer to make sure that the systems are integrated and are very efficient. Industrial and systems engineers also play a huge role in warehouse design. How do you design warehouses? How do you design facilities? So there's one module called layout and facility design, and that's where industrial and systems engineers play a role. This will be, it can be a warehouse to supply production, or is a warehouse to supply medication to the doctors, or warehouse that supplies beds or operating equipment, or all those things. Here we are saying that the value of industrial engineering is that industrial engineers develop job evaluation programs amongst other duties. And the important thing is to eliminate waste, to ensure that systems are efficient, and the role will be to integrate. And I think from Learning Unit 1, we spoke about the role of an industrial and systems engineer is to ensure that you integrate people, being human resource, people, equipment, energy, information, because now we are living in the information age. How do we ensure that we optimize information and we are able to make the right decisions at the right time? Without the right information at the right time, at the right speed, we might tend to make bad decisions. So how do we ensure that we integrate information flow into decision making? For instance, it can be in a hospital, it can be a matter of life and death, the issue of speed of information. If we don't know things and we take decisions that we are going to regret. So how do we ensure that we are able to amass all this information that is sitting everywhere into one from a big data point of view, so that we can make the right decisions at the right time, at the right speed, which is very important, at the right speed, because it doesn't have to take a decision after 2 months when the ship has sailed. It doesn't help anyone. I think that was the presentation from us. Maybe we can get some comments and questions, and maybe Prof. Ramdas, you want to say something before we go to the questions and answers?
Just a few words, Kabo. So as we've seen that industrial engineering applications can be applied anywhere and everywhere, even in your kitchen. You know, when you're making a cup of tea, you know, you can basically look at optimizing your resources that are there. When you are making something to eat for yourself, making lunch or dinner for yourself. So these applications are there, but we quite often, you know, as industrial engineers, it is in us to basically look at, you know, all these little things that can make big differences. So industrial engineering is a systematic methodology to basically evaluate situations so that we can optimize and also reduce in the same space. Optimize meaning optimizing your outputs, optimizing what you want to achieve, but also minimizing maybe the costs of what you want to achieve. So as we've seen, it can be applied anywhere and everywhere. It can be applied in your individual life. How do you maximize the time you have? How do you maximize on your education to become better students? How do you optimize in focusing on what you do in terms of educational requirements, educational needs, and so forth. So it is not only that it is not something that can be applied to anything that we are investigating, but it can be applied to ourselves as human beings. As human beings, we need to optimize whatever we have in terms of reaching our goals for a successful life ahead. Thank you so much, Kamo.
Thank you, Prof, for that insight. And you can see that industrial and systems engineers can work practically everywhere. And I think the more society and decision makers are aware of this profession and they are aware of the value that they can extract from industrial and systems engineers, the more the quality of life in the service industry will actually improve. I see Patricia, your hand is up. Dr. Hoss, go ahead.
Yeah, I'm sitting here and I'm thinking, how cool will it be? I know we don't have time in this session, but then to run a practical workshop, and we kind of take the participants through a number of steps. So pose the problem and then actually work through it. Might maybe take a couple of hours though, just to show them how the sessions work and how the simulations can add to your data collection, and how you can run numbers and analyze and take runs and measurements and identifying all the variables that are needed actually to get to. I should have been an industrial engineer, coming to think of it. Thank you. Thank you.
Thank you, Dr. House. Yeah, in fact, I think most of us should have, or if we knew that about this qualification or this career, most of us would have chosen it. You know, I also became an industrial engineer after I first studied chemical engineering. So I worked as a chemical engineer, and then one day I didn't know about industrial engineering, because where I studied there was no industrial engineering. It was mainly the top 5 or the well-known engineering: chemical, electrical, mechanical, civil, and yeah, I think those 4. So then I saw something. I was like, what is this thing? Then I read about it. I said, no, I want to do it. Then I went to my employer. I said, I want to do this thing. You must take me back to school. I'm going to do it. And that's how I got into industrial engineering. I didn't know about it. But it is a very awesome qualification and career, which is broad. I mean, Prof also worked mainly in manufacturing, but in the clothing industry, in the electronics industry, and also now in higher education. I worked in CSIR, which is a research institute. Then I worked for Volkswagen, which is a manufacturing industry where we were assembling cars. Then I worked for the post office, where it is a service industry. Then I left post office, worked for the DTI, one of the programs of the DTI, which it was more of a consulting industry, because we were consulting with SMMEs. Then I worked for Pyromet, which manufactures furnaces, but as a process engineer, but doing more industrial engineering work. Then I went back to the post office. I worked as an industrial engineer, worked in sustainability, which is also part of industrial engineering. So it is quite broad, and you can literally work anywhere. And the hospital example, when I joined UNISA, we spent some time at, what is the name of that hospital in the East Rand? I forgot the name, but colleagues were there, you know, to assist with patient flow. How do we optimize flow? And, you know, when we are there, and I don't know why it was like that, but when we were there, you know, patients were saying, but what are you guys doing differently? Because if I'm here by 7, by 11 I'm out, but when you guys are not here, I leave here at 3. because we will go and talk to we will start at casualty, see what the doctors are doing and say, but why are you doing it like this? Can't you maybe consider doing it this way? Then we will go to even a triage where they decide whether you must, you are a, what do they call it? I think it's a priority thing. They bought a robot. If it is red, the symptoms are red, you must immediately see a doctor, or you must go to emergency. If it is yellow, you can stay a bit. If you are orange, you are on the borderline, maybe, maybe not. So, you know, talking to all these guys and also going to, because one of the bottlenecks was pharmacy. So you have all these people that are seeing the doctors and you optimize that, and then the line is quicker there, but then it gets stuck at pharmacy. Then you have a bottleneck there. So the pipe it narrows in pharmacy. Then how do you optimize it? Then we go in and say, what are the issues? What is the process? We document the process. Okay, this is how you guys are doing it. But if you improve it this way, if you do it this way, will it assist? Then they implement. There and then they implement, because we had a support from the hospital manager or the CEO himself, who's also running around making sure that, you know, the guys are doing what they are supposed to do. But all this sometimes it needs a good change management aspect, which is also another leg of industrial engineering. Because if you don't do change management, when the intervention team leaves, then the staff goes back to their normal, which is their normal, and then they go back and relax and go back to their normal and recalibrate, and then everything goes haywire again. Prof. Ramdas, go ahead.
So we can do a simple example tomorrow. What our students need to do today is that they need to make a cup of tea. So they need to document every process, every step that they do, and each one will present how they made that cup of tea, the process flow, as well as the time it took to make that cup of tea. And then we can discuss it tomorrow to see how we can optimize that process of making a cup of tea. Thank you so much.
Thank you, Prof. That is an interesting one. What is the feeling here?
That's very doable. Very doable. Thank you.
Yeah. Okay. So maybe tomorrow you can use your cell phone as a timer. From this time you start making the tea. What are the processes that you are following, and how long does each process take until you finish making the tea? Then we can try to improve that process tomorrow, because industrial engineering is about processes. As long as there's a process, it can be improved, and we can reduce waste. And also, while waiting for the tea or boiling the water, what do you do?
No. That they need to think about, Kabod. That simultaneous actions will be done by them thinking about what they're doing.
Okay, so just document everything you do.
Yeah.
All right. No. Okay. Also, Professor Ramdas, you think I'm giving away the solution now? So everyone will document, and in between, what are they doing? How long do you wait until the water boils and stuff like that? So then we can tomorrow discuss further.
Awesome. Thank you.
Okay. No, thank you. I think this was the third one. So tomorrow we'll do the fourth one, and yeah. So we hope by tomorrow we'll have a more interactive process. Absolutely. Where each and every one of us will show what they were doing, how they did the tea or the coffee, whichever you like. And Kabelo, your hand is up. Go ahead.
Do you ever get to a stage whereby you see something else good enough and not needing any improvement?
I'm sure they, hence the concept of continuous improvement. There is this thing that if it is not broken, don't fix it. But it might not be broken, but it takes forever to run, or forever to produce whatever result that you are trying to do. So what can you do to make sure that you are as effective as possible? Maybe when you reach 100% efficiency, maybe there's nothing much you can do about that process, but then it means what else can you do better? Maybe this process has reached its capacity, and maybe you can say, okay, we're going to design something even better. So I think there's always something better to do. I don't know. Yeah. Is your hand still up, Kabelo?
In fact, we can apply industrial engineering to our university, and it will change everything that we do.
Yeah, no, definitely. Yeah, definitely. Kabelo, go ahead.
Well, it's an all-round, but I was trying to look for a participant, but I think they got cut off because of network. It's the first year student from UJ, because I can see it's coming in and out.
Oh, okay. Sorry, man.
I invited them to the station.
Oh, okay. Hopefully they will join us tomorrow, hopefully.
Yeah.
Okay, thank you. I will take the reins back to Kabelo. Your hand is up again.
The old end.
Oh, okay. Thank you. Thanks, everyone, for attending, and I would like to hand over back to Tumelo and Patricia for the closing.
Tumelo, you can close the session. Thank you.
Yes, Prof.
If you can please stay behind, I need to speak to you for 2 seconds.
That's fine. I'll do so. Okay. Tumelo, to you, sir.
Thank you so much, Professor Khabo, and to your colleague. Thank you so much to our online participants, as well as for those of you who are watching our recording. Thank you so much for taking the time and effort to watch the recording. I hope you really enjoyed. For more information regarding today's session, please don't hesitate to email us on i-set@unisa.ac.za. The recording will also be available on our MOOC portal. If you are not part of the MOOC portal, don't also hesitate to email us also on i-set@unisa.ac.za, and then we'll certainly attend to you. Otherwise, see you tomorrow for our last learning unit. I'm looking forward to it. Have a lovely Wednesday. Thank you.
Bye, everybody. Thank you. Really enjoyed this. Bye-bye.
Bye-bye.